Lesson 35, talking about locating and using intercepts. Do I have your attention? I don't think I do. All right, great, that's better. All right, so today we're going to be talking about linear equations, lines on a graph, okay? And linear equations can be graphed if we make a table of ordered pairs that satisfy the equation. So, you know, if I take a linear equation, something really simple like maybe y equals 2x plus 3, right? I could make a table of values for x and y where, let's go with like 1, 2, 3, right? 2 times 1 is 2, 2 plus 3 is 5, so my coordinate pair there would be, I would plot the position 1, 5. If I went 2, I'd get 2 times 2 is 4, 4 plus 3 is 7, so I could plot the coordinate pair 2, 7. And 2 times 3 is 6, 6 plus 3 is 9. I could plot the coordinate pair 3, 9. And then I could connect all three of those points and I would have my line, right? Okay, so we're familiar with that method of graphing, is just making a table of values. All right. An ordered pair or set of ordered pairs that satisfy an equation is called the solution of a linear equation in two variables. What I've got represented there is that solution of linear equation in two variables. When an equation is in standard form, the linear equation can be graphed another way. Okay, the standard form of an equation looks like this. Now that's algebraic, meaning that A and B and C, A and B represent coefficients and C represents the constant. And we are familiar with what those words mean, right? Coefficient and constant. Okay. All right, so that's our standard form. It's where we would have our x value and our y value on one side of the equation and our constant on the other. Okay, and A and B are both not 0. Okay, so the x-coordinate of the point where the graph of an equation intersects the x-axis is what we call the x-intercept. For instance, if I make just a really general graph here, okay, and I got a line that comes across here, this position is called the x-intercept, okay, where it intercepts the x-axis. We may be a little bit more familiar with the y-intercept, right, because we've seen the y-intercept form or the slope-intercept form of the equation where we see something like this. That would be the y-intercept, but we also have x-intercepts, all right? So the y-coordinate of the point where the graph of an equation intersects the y-axis is called the y-intercept. You're familiar with that. And the coordinate pairs for these things would be x, comma 0, meaning that where I have my x-intercept, y equals 0. Okay? And where I have my y-intercept, x equals 0. You follow me so far? Okay? That satisfies a linear equation are two solutions of the linear equation in two variables. So let's go back to our earlier equation I put up here. It was what? Y equals 2x plus 3? Okay, something real basic. We could, instead of trying to plot those 3 points, we could plot just 2 points and still connect our lines by finding the x-intercept and the y-intercept. Let's see what's on this next page. We may have a little bit more room to work with. All right. So that's what this is talking about. An efficient method for graphing a linear equation in two variables is to plot that x and y-intercept, the single point where it crosses the y-axis and the point where it crosses the x-axis. Then we just draw a line between those 2 points. You follow me so far? Okay. Any linear equation can be arranged into standard form, putting both variables and the coefficients on one side of the equal sign and the constants on the other. So where we had something like y equals 2x plus 3, we could very easily make this negative 2x plus y equals 3, right? Or even y minus 2x equals 3, okay? So with this, though, let's say I didn't want to go to all of the work of plugging in numbers, right? And I just wanted my x and y intercept, all right? So, like I said, the x-intercept is where y equals 0, right? Okay, so what I can do here is do negative 2x plus 0 equals 3. And what would I do to solve for x? Subtract 0. Okay, I've subtracted 0. I still have negative 2x, right? Okay, then what? Divide by what? Divide by 3? No. Divide by negative 2. All right, so x there would equal negative 3 halves, correct? So negative 3 halves, that's what, negative 1.5? All right, so let's just say it's about right there, okay? Now, so in terms of a coordinate pair, what I'm getting there is because the y was 0, I get negative 3 halves 0, okay? Now, if I erase this here for a second, we can switch gears. And we can say negative 2 times 0 plus y equals 3. What's negative 2 times 0? 0. 0 plus y equals 3. What does y equal then? Y equals 3. So, over here, I have 0, 3. My other point, let's say, is about there, and I can connect those two lines. Okay, didn't do a very good job of connecting them, but you guys get the general gist. If you want to know what the x-intercept is, plug in 0 for y. If you want to know what the y-intercept is, plug in 0 for x. Okay, does that make any kind of sense to you guys at all? Okay, another way to look at it is just set it up like this, where I have x, y. I'm going to do 0 and 0 and solve for the other set. Okay, so I can still set it up as a table of values. Okay, but that means I only have to plot 2 points. I'm not saying it's necessarily always easier to do this, because you'll notice we got a negative 3 halves. You might get an unfriendly number to graph. All right, let's see, that looks like it for that. So let's take a look at some questions we can address. Okay, question number 1 here. What is the y-intercept, for negative 3x plus 5y equals 15? Well, if I wanted to know what the y-intercept is, where do I plug in 0? Or what do I plug in 0 for? For the x value. All right, so if I'm going to rewrite this equation for that, what am I going to rewrite? Reagan? Negative 3x. Oh, negative 3 times 0, good. Plus 5y equals 15, very good. All right, what do you do next? So negative 3 times 0 is 0. So basically what we're saying is that anytime I plug in 0, I can just cancel out whatever's attached to it, right? I don't even need to bring in 0 down. So what am I simply writing next? 5y equals 15. Divide by 5. Y equals 3. Y equals 3. Okay? Feel pretty good about that? Okay? Not too bad. Okay? All right. Let's look at the next one. Next one adds a little bit. It wants to know some more information. It says use the intercepts to graph negative 3x plus 3y equals 18. Blayton, let's say we want to figure out the x-intercept. What do I do? Okay, cancel y out or plug in 0 for y. Okay, so in the end, what would you end up rewriting your equation as? Negative 3x equals 18. So what's x going to equal? Negative 6. Okay, so we know we're going to cross the x-axis at negative 6. And I have 2 of them that have that answer, right? Both C and B have that. So do I need to go ahead and find the y-intercept as well? Okay, Tiffany, help me out here. How would you find the y-intercept then? All right, so she said substitute in 0 for x, which is going to cancel out negative 3x. Then what? So we're going to write 3y equals 18, and then you're going to divide by 3, and you're going to get y equals 6. All right, so we should be at an x-intercept of -6 and a y-intercept of +6. Right, and I can plot those points between it. Notice on B, they said that the y-intercept was 22/3, which is incorrect. So we understand that C is our answer, right? It's feel even easier now as we've done a little bit more. Okay. All right. Here we should be able to just simply look at it, right? Let's see, Mia, what is the y-intercept here? Y-intercept is 2. Good. And what is the x-intercept, Jordan? 1. Good. X-intercept of 1, y-intercept of 2. I think C is your answer on that. Let's see, number 4, C. Good. Okay, now we get into word problem. Okay. A clothing manufacturer needs 2.4 yards of fabric to make a jacket, 1.6 yards of fabric to make a matching skirt. The number of jackets is X, the number of skirts is Y. That can be made from a 48-yard bolt of fabric represented by the equation 2.4x plus 1.6y equals 48. We want to graph the function and find its intercepts. What does each intercept represent? Okay, so let's go ahead and solve for our x and y intercepts. Okay, if I want to solve for the x-intercept, Abby, what am I going to do? Yep, if I want to find the x-intercept, what do I do? What do I plug into my equation? No, not in this case. Christian, what do we do? If I want to solve for the x-intercept. You don't get it? All right, why don't you move up here to the front row? All right, so let me hit this again, just because either one, we don't get it, or two, we're not really paying that close attention. If I want to solve for the x-intercept, okay, sub in 0 for the y value and solve for x. Okay, if I want to know what the x-intercept is, I'm going to sub in 0 for the y value and solve for x. Can we do that? All right, so I've got 2.4x, okay, plus 1.6 times 0 equals 48. Okay? All right, what's 1.6 times 0, Christian? 0, so I can just get rid of it, right? So that gives me 2.4x equals 48. How are you going to solve for x? Divide by 2.4 on both sides. So 48 divided by 2.4, x equals what? 20. Okay, 20. All right, now I could rewrite all of this, but here, I'm going to do something just real basic here. If I want to solve for the y-intercept, okay, sub in 0 for the x value, right? Does that make sense? Okay, so as I come in here, we'll get rid of this here for a second. Instead of subbing in 0 there, I'm going to go ahead and put my y back. I'm going to come over here, and I'm going to write 2.4 times what? 0. All right, Abby, can you help me out here? What's 2.4 times 0? All right, so how can I solve for y in this situation? Because I know 1.6y equals 48, right? Because we got rid of that. No, I don't want to divide 1.6 by 48. You're close. We do want to divide. I'm trying to move the 1.6 over to the other side. I want to solve for y. So if I'm not dividing by 48, what am I going to divide by? 1.6. All right. All right, what's 48 divided by 1.6? Abby? What's 48 divided by 1.6? Are you getting it better now? Okay. Go ahead. Here you go. $30. All right. So keep in mind, what did X represent up here? In my information, what is X? Jackets. Okay. And what is Y? Skirts. All right. And what they're telling me is that I only have so much material I can make. You know, it uses so much material to make a jacket. It uses so much material to make a skirt. So what does the 0 represent? Whenever I plug in 0 for X or 0 for Y, what am I saying about what I'm doing? Like when I plugged in 0 for X, what was I saying? How many jackets was I making if I plugged in 0 for X? I was making 0 jackets. I was putting all of my fabric into making skirts, right? And then whenever I plugged in 0 for Y, what was I saying? I'm making how many skirts? 0. And I'm throwing all my material at making jackets, right? So let's say that we do this by, let's do it by 5s, right? 5, 10, 15, 20, 25, 30. 5, 10, 15, 20, 25, 30. Okay? So where do I want to put this, let's say on the y-axis? What's my y-intercept? 30. So 5, 10, 15, 20, 25, 30. Okay? My x-intercept is where? 20. 5, 10, 15, 20. Okay, we're going to connect. And what we're saying is that anywhere in between, all right, so long as I'm on the line, I will use exactly the amount of material needed. I could make different combinations of jackets and skirts together, right? Does that make sense? All right. And because we can't make negative jackets or negative skirts, we're pretty much stuck in the first quadrant. Does that make sense? Yeah.
On the homework when it says like find the x and y or whatever, do we put a graph on there?
Does it say put a graph?
No.
All right. If it doesn't say put a graph, let me look at what question you're talking about. 10 and 11. No, you do not have to have graphs on 10 and 11. But in the practice set, like B and D, you need to have graphs where it says graph, right? So B and D will require you to have a graph. Okay? Any other questions? Let's see. You guys are out of here at 36, so the bell should be ringing. Right? 48. Oh, we got a couple minutes here. Let's see. But I think this type of question is probably the hardest in terms of what you're going to have to do. Abby, do you get a little bit better now than you did? Christian, you feel like you're in good shape? Okay. Let's see if there's anything else in here that you really need to. We do have some more. I'm wondering, okay, so these would have been the graphs that would have gone with that question, where we would have wanted 30 and 20. We would have gone with D as our answer. The x-intercept is 20. The x-intercept gives the total number of jackets that can be made from one bolt of fabric when only jackets are made. The y-intercept is 30. The y-intercept gives the total number of skirts that can be made from one bolt of fabric when only skirts are made. Does that make sense? Okay. The rest of this is giving you x and y values. So what you want to see, if I'm looking at a table of values, this is my y-intercept, okay? Is this 0, 5,000. Okay, my x-intercept is at 8. Does that make sense, just looking at it? All right, so I'm looking where the other side is 0 at. Okay? What is the x-intercept on this graph? Anybody know? Caden? What's the x-intercept there? -5. Very good. Okay. I think that you guys are probably pretty good at this point, right? If you guys have questions or you're struggling, let me know.